Okay, remember we are doing inequalities. So anytime you have an inequality that is less than or greater than, you're going to create a dashed line. Okay? Anytime you have less than or equal to or greater than or equal to, it's going to be a solid line. Just remember that. Okay, remember on number 1, we talked about, look at the inequality first. Notice that it's greater than, so this is going to be a dashed line. First of all, you need to find your y-intercept. In this case, y-intercept is -5, so right here. Let's put a good dot there. And then we have a slope of 1 over 3. So I'm going to go up 1 to the right 3. I'm going to put another dot, up 1 to the right 3. I'm going to go down 1 to the left 3. Now notice this creates a nice little line. So what I'm going to do is I'm going to try and create a dashed line through those points. Now I'm going to try the best I can. So basically, I don't have a ruler, so just bear with me. All right, now, what I'm going to do is what you have to figure out which side you're going to shade on. So we're going to use this point of 0, 0. And in doing so, what you have to do is you have to plug that point in. You have to test it. So I'm going to plug in point 0, 0 for y, greater than 1/3 times 0 minus 5. Well, 1/3 times 0 is 0. And 0 minus 5 is -5, so 0 is greater than -5. What you have to decide is whether or not that is true or false. If it is true, that means 0, 0 would be a solution. Therefore, you would shade this side of the field. You would shade this side. All right? In this case, 0 is greater than -5, therefore it is true, so therefore this whole side would be shaded in. Now you don't have to shade the whole thing in, just enough to where I know that you know it's above the line. On the next problem, y is less than or equal to -2 minus 1. Notice in this case it is a solid line, so it's going to be less than or equal to, so it has to be solid. Now my y-intercept is at -1, so I'm going to put a dot at -1. Let me make that a little bit bigger. Okay. Then I have a slope of -2 over 1. So I'm going to go down 2 to right 1, down 2, right 1, and I'm going to go up 2, left 1, up 2, left 1. All right. Now, I don't have to fill them all in. Sometimes it's a good idea. Sometimes it's a good idea to do that. So what I'm going to do instead is I'm going to go ahead and draw a line. I'm going to try the best I can. Now, it has to be a solid line, so I'm going to try the best I can to get it as straight as possible. All right. Now, I'm going to use the point 0, 0. So here's my point 0, 0. When I plug that in, 0 less than or equal to -2 times 0 minus 1. Well, -2 times 0 is 0, so I get 0 is less than or equal to 0 minus 1. 0 less than or equal to 0 minus 1 is -1. Now, I know that 0 is greater than. Well, since that's the case, this is not true. Okay, so this is not true. It doesn't make this true. So therefore, 0, 0 is not a solution. So what I end up doing is I shade the opposite side. And that's basically what you're doing. You're testing using the point 0, 0 to see where the shading is going to be. On this problem, you have to solve for y, or at least that's one of the ways you can do it. Now, in doing so, what we can do is we're going to solve for y. So I'm going to take 5x minus 2y is greater than 12. I'm going to subtract 5x on both sides. And I'm going to cancel that out. I'm going to bring down my -2y greater than -5x plus 12. Now, this next step, I'm going to divide by -2, but there's something really peculiar about this. When you divide by a negative, the inequality sign has to flip. So now it's going to be y is less than, now negative over negative is a positive, so that's going to be 5 over 2, x, and then 12 divided by -2 is -6. So now I have a point at -6 and a slope of 5 over 2. So let me clean some of this up because I can't have all of it there. And then what I'm going to do is, once I clean all this up, I'm going to rewrite it. Let me just do this right here. So Let me delete all that. So like I said, what you end up getting is y is less than 5 over 2x minus 6. So I'm going to put a dot at negative 6. Okay, let's make that bigger. All right, so I'm going to put a dot at negative 6. And then I'm going to go up 5. 1, 2, 3, 4, 5, and over 2. So another dot there. And again, 1, 2, 3, 4, 5, and over 2. All right, I'm going to do it one more time. Now, I'm going to go ahead and draw a line. Now, notice this indicates, oops, sorry, that's a little bit too big. That indicates, if you notice this right here, that means my line's got to be dashed. So I'm going to make this a little smaller line. All right, so now I'm going to have a dashed line. Oops, not too good right there. So again, it's just got to be dashed. And try to make it go through those dots, all right, as best as possible. Now I'm going to try the point 0, 0. Now I can either put 0, 0 in this equation or this one. I'm going to choose to put it here. So 5 times 0 minus 2 times 0 is greater than 12. Well, 5 times 0 is 0, 2 times 0 is 0, and 0 minus 0 is 0. So is 0 greater than 12? The answer is no. So that means this point of 0, 0 is not a solution. Therefore, you have to shade on the other side, which would be this right here. Now, on this particular problem, this is the same scenario, but I'm going to do something a little different with this one, okay? What I'm going to do is I'm going to use my y-intercepts to graph this. Actually, if I plug in 0 for x, that leaves me with negative 4y is greater than 8. Well, actually, remember, if you remember, I'm going to put an equal sign here. I end up getting negative 4y equals 8, so therefore negative 4 times something is 8. Well, when I divide by negative 4, I get y is equal to negative 2. So I have a point of 0, negative 2 as my y-intercept. So I'm going to go ahead and delete this, okay? Let me go ahead and delete this. I'm going to erase all this right here. And then I'm going to plug in my 0 for my y and see how that works out. Well, when I do that, when I plug in a 0 for y, I get x minus 4 times 0, and remember I'm going to put an equal sign there instead, is equal to 8. Now that's gone, so I get x is equal to 8. Well, that gives me the point of 8, 0. So now that I have 2 points, I'm going to go ahead and graph those two. All right, so here we go. I'm going to graph these points. So I got a point at 8, 0, which is over here. And then I have a point at 0, negative 2, which is right here. Now, one of the things you can notice is this. If you look at the slope, this is a rise of 2 and a run of 8. Well, if you have a rise of 2 over a run of 8, that's a slope of 1/4. So I can find another point by going up 1 and to the right 4. And that's what I'm going to do. So let me erase this so I can get this out of the way. In fact, I didn't want to do that. So at any rate, let me go back and put my points back in. So I had it at 8, 0, and I had it at negative 2, or 0, negative 2. Now, like I said, remember it was 1 over 4, so I'm going to go up 1 to the right 4, and there's another point. That means I can go down 1 to the left 4. Now, if you notice, I can do that one more time. And now I have a series of points that I can connect. I'm going to go ahead and connect those. And I'm using, now in this case, remember, this is making me do a dashed line. So I'm going to try the best dashed line as possible. And again, without a ruler, it's kind of hard to do that. All right, so now I'm going to test the point 0, 0 to see if it's a solution. Well, I'm going to plug it in. So let me go ahead and erase this. I'm going to plug in 0, 0. So 0 minus 4 times 0 is less than 8. Well, that all cancels out and you end up getting 0 anyway. And 0 is less than 8, so 0, 0 is on the side of the solutions. Therefore, all of these over here are my solutions. On this one, remember y equals is a straight line, but you've got to remember it's a horizontal line. So if I go to -4, I can put now this is going to be solid based on that right there. I'm going to put -4 right there. It's solid. Now I'm going to test the point 0, 0. So if I test the point 0, 0, that's this point right here. If you notice, there is no x. So I don't have to worry about plugging in the x. So what I'm going to do is I'm going to plug in the y, so 0 less than or equal to 4, and 0 is less than 4, therefore this is one of the solutions. So I can just fill in this side. Now let's try the last one. This last one is x is greater than 7. That's the same as saying x is equal to 7. So I'm going to go over to 7. That's a vertical line. So this is a dashed line because of the inequality. Now again, I'm going to test the point 0, 0. Well, there is no y value, so I'm not going to test that. So I'm just going to test the x. So 0 is greater than 7. That is not true. Therefore, shading is on the other side. And that is your introduction to inequalities with systems.